Welcome to Physics Can Be Fun with me, Stephen Thomas. Today we're doing this question 10, which is on fertilizers. It comes from last year's Matric Physical Science Chemistry paper in 2018. So here we see question 10. In the flow diagram below, 1 and 2 represent industrial processes used in the fertilizer industry. P and Q are chemical reactions that take place to produce ammonium sulphate and fertilizer Y, respectively. So let's just have a look at this flow diagram. They seem fairly keen on flow diagrams. Nothing wrong with flow diagrams. We see here nitrogen plus hydrogen goes to form ammonia. You've got to learn that that is called the Haber process. So number 1 is the Haber process. Let's have a look at number 2. Ammonia goes to form nitric acid, HNO3, and you're going to have to just straight learn memory work that is called the Ostwald process. Let's just have a look at the memorandum. There you see it, Haber process, Ostwald process. You can find the memorandum also on our Physics Fun forum, or you can go to WCED past papers and then it'll give you the memo. So we just got to learn the Haber process and the Ostwald process. Let's go back to the paper. Write down the name or formula of fertilizer Y. So here we start with ammonia, NH3. We add HNO3, and we're going to end up, if you add those together, we're going to end up with ammonium nitrate. There's the ammonia. It grabs one hydrogen, it becomes NH4, that's ammonium, and it's left with nitrate. So that's not so hard to remember, is it? Let's have a look on the memo. Ammonium nitrate, NH4, NO3. You're just adding the two together, so you could almost do it without any knowledge. Back to the question. And then the catalyst used in process 1 is iron oxide, or just plain rust, like a rusty nail. That is the catalyst. You just got to learn it. In reaction P, ammonia reacts with other substances. Write down a balanced equation for this reaction. In reaction P, ammonia reacts with other substance, or with another substance. Write down a balanced equation for this reaction. So we've got to know the name of ammonium. Well, we've already seen that ammonium is NH4 and sulphate is SO4. So how do we go from that, NH3, to SO4? Well, we've got to find hydrogens for this ammonium. And we've also kind of got to know that sulphate is something with 2 hooks, and ammonium is something with 1 hook. So we need 2 ammoniums for 1 sulphate. Sulphate acts as if it's in group 6, and ammonium acts like it's in group 1. It's got 1 hook or 1 valency, so we need 2 ammoniums. And this is something that should be taught really even from grade 9, the formula of ammonium and the formula of sulphate. So let's go to the memo, and we will see that it's not that hard to see that we need 2 ammonias, 1 sulfuric acid to form ammonium sulphate. You've got to see that that's got a valency of 1 or 1 hook, and this requires 2 of them to join with that. And so we're only allowed to put 2's in front. So when we add a 2 in front of the ammonia, we get 2 ammonias, and there that we must know the formula for ammonium sulphate is NH4 in brackets twice SO4. So there's a little bit of basic chemistry which they begin to reintroduce into Matric, and I like it. We've got to know the name, or we've just got to memorize it. How hard is that? And you see there's the answer, iron oxide, from the previous question. So let's go back to our question. So we could almost roar through this. Now here we come to 5-mark question. The following substances are present in a bag of fertilizer. 20 kilograms of ammonium nitrate, which we've discussed, 12 kilograms of sodium phosphate, Na3PO4, 18 kilograms of potassium chloride, KCl. Calculate the nitrogen. There's phosphate or phosphorus and potassium ratio. And always in a bag of fertilizer, you're going to find NPK, N colon P colon K equals 1:2:3 or 1:1:1 or something like that, some ratio. So we're going to work out the ratio of this fertilizer. So that's all they're asking. So what we've got to do is find out how much N and N is in this substance here. How much phosphate, there's one phosphorus in this whole molecule of 3 sodiums and 4 oxygens and 1 phosphorus. So they're asking us to work out what fraction of the weight of this is nitrogen. So what we've got to do is work out the molar weight of NH4N and O3, and then work out the weight of nitrogen percentage, or what fraction of it is nitrogen in this whole molar mass. So what we're going to do is we're going to go to our BFF, or we're going to go to our periodic table, and we're going to look for where we find the atomic weights. So hydrogen's atomic weight is 1. Sorry, this is sideways. Nitrogen is 14. You see it's below. There's the atomic number. There's the atomic mass. There's 14. Oxygen is 16. So what we've got to do, going back to the problem, is we're going to add the 14 plus 4 times 1 is 4, plus 14 plus 3 times 16, and we're going to get the final molar mass of that molecule. So let's get our calculator and let's just work it out. So we're going to get nitrogen is 14 plus hydrogen, there's 4 of them, which is 4 times 1 is 4, plus another nitrogen, which is another 14, plus 3 oxygens, so that's 16 and 16 and 16. And so we see the final mass is 80. So if we now want to calculate what fraction is only nitrogen in out of 80, we know that the 2 nitrogens are 14 plus 14 is 28 upon 80 times the 20 kilograms. So let's do that. Let's work out what fraction. It's 28, that's the 2 nitrogens combined, 14 plus 14, divided by what we worked out was the molar mass, times 20 kilograms. And that tells us that 7 kilograms of that 20 is those 2 nitrogens. And we do the same for the phosphorus and for the potassium. Let's just go to the memo and see how that looks. So, going back to the memo, you'll see that they've also done that. They've worked out the molecular mass of that is 80. And they know that of that, 28 grams is nitrogen. So, of the 20 kilograms of that ammonium nitrate, they have 28 upon 80 times 20, which is 7 kilograms of that is actually nitrogen. So then when they work it out, they find 2.27 kilograms of that is phosphorus, and they work out that 9.42 kilograms of that is potassium by the same means. And then they come to the ratio is going to be 7 is to 2.27 is to 9.43, which is approximately 3 is to 1 is to 4. If you multiply, you make your lowest one 1. If you multiply that by 3, it comes to approximately 7. If you multiply this by 4, it comes to approximately that. So we're going to give the approximate 3 is to 1 is to 4. And so there we see is our answer. So go through the methods and then just scratch out that you just want to learn one method. Scratch out all of this. You don't want to learn any more than one method. If you don't like that method, go to another. So in summary, can we learn from this? Well, we've learned the Haber process is nitrogen plus hydrogen. We've learned the Ostwald process is when to form ammonia. If we take the ammonia and we go and form nitric acid, that's the Ostwald process. We know that the one reaction where we took ammonia and nitrate and we got ammonium nitrate, that's a fertilizer. And we know that for the Haber process we need iron oxide, which is rusty iron. Here is a balanced reaction to make ammonium sulphate, which is another type of fertilizer. Ammonium nitrate, ammonium sulphate. So we've learned quite a lot, and then we've worked through a problem in which we can work out the ratios of N is to P is to K, and that is a commonly asked type of question. So we've already learned quite a lot about fertilizers just by working through this one problem. And that is why I say it's imperative to work through past exam papers. It's one of the easiest, most wonderful ways to improve your chemistry